Complex number, lecture number 1. This is normal in A2 topic. We have already studied about this in AS, where in quadratics, you used to have b square minus 4ac less than 0. B square minus 4ac less than 0 used to tell us that this is your discriminant showing that curve and line does not meet, because b square minus 4ac less than 0 means that in under root b square minus 4ac, if it is less than 0, so that means under root -1 will always be, or any number will be complex number, or it used to be the imaginary roots. It used to have imaginary roots. Now, the whole of the complex is basically revolved around this under root -1, because in under root -1 is basically your iota, which means -1 to the power half. So anywhere where you see under root -1, you can always write down this thing as iota directly. Similarly, if it is iota square, iota means under root -1, but there would be square over the bracket, which means this under root is -1 to the power half, and there is another power after the bracket. So 2 ones is 2, 2 divided by 2 will be -1. So that means iota square value is -1. Let's just recall this. If we have under root -1 square, this under root will be changed to half. And when we multiply this 2 with 1, we get 2 ones are 2. So 2 upon 2 is 1. So -1 upon -1 to the power 1 will be -1. So that means iota square will always be -1. If we have iota cube, which means under root -1 to the power cube, this will be -1, whereas 3 upon 2 will be used, because iota cube means this under root is half. Half multiplied by 3 will be 3 upon 2. If we further break this thing down, this should be -1 to the power 1 and -1 to the power half. So -1 to the power 1 is already negative, but half minus 1 to the power half means iota. So this should be negative iota, because if you see, this negative will give me negative value, but this particular -1 to the power half under root means under root -1, and under root -1 is basically your iota. So the end result will be negative iota. Then you have is iota to the power 4. Iota to the power 4 means under root -1 to the power 4, which means -1, and this should be 4 upon 2. When this is 4 upon 2, that means -1 to the power 2 upon 2 will be 2, and the end result will be 1. Now, considering that we already know that under root -1 is iota, so we can always write down iota as under root -1. Iota square will be -1. Iota cube will be negative iota. Iota to the power 4 would be 1. In similar state, if we just have values such as iota to the power 5. Iota to the power 5 will be known as iota. Iota to the power 6 will be known as -1. Iota to the power 7 will be negative iota. Iota to the power 8 will be 1. Then again, if we start iota to the power 9, iota to the power 9. So iota to the power 9 will be iota. Iota to the power 10 will be -1. Iota to the power 11 will be negative iota. And iota to the power 12 will be 1. So there are only 4 values that are determined through the iota. Any value you put down, your value will be used within just the iota, -1, negative iota, or 1. So this is the normal basic, because these values are used in further complex number. That means the 4 values iota, -1, negative iota, and 1 will be used in the further complex number lecture. Now let's do some example question. Let's say we have under root -4. Now, what does this under root -4 mean? Under root -4 means that we have 4 into -1. That means this under root can be obviously distributed in 2 parts. That means there should be 4 and -1. So under root 4 is basically 2, and under root -1 is iota. So that means under root -4 will be known as what? 2 iota. Similarly, if we have under root -9, under root -9, this will be solved as 9 into -1. So this should be under root 9, under root -1. This should be 3 iota. Similarly, if we have -12, this can be, the LCM for this should be 4 into 3 into what? -1. So under root 4, under root 3, and this should be iota, because under root -1 should be iota. So the answer for this is 2 under root 3 iota. So such questions can be tested in the radical sign, which is your under root. That means in the question, if there is negative power, you can always change it to under root, and you can change it to what? Iota itself, using the square root. A normal quadratic equation is given as y is equal to ax square plus bx plus c. If we say a quadratic equation is given, how to evaluate roots? So to evaluate roots in complex number, we use -b plus minus under root b square minus 4ac upon 2a. Minus b plus minus under root b square minus 4ac upon 2a. Now let's just work through the example. 2x square plus 4x plus 32 is equal to 0. Now knowing this, that this is your a, this becomes your b, this becomes your c. Your formula is -b plus minus under root b square minus 4ac upon 2a. So if we just change this thing x, this will be -4 plus minus under root 4 square minus 4 to 32 upon 2 into 2, which means the value that we will be getting is x is equal to -4 plus minus under root 16 minus 4 2s are 4 3s are is 120. This should be 256 upon 4. If we just solve this further, we will have -4 plus minus under root 240, but negative upon 4. Now, if you see there is plus and minus sign. So if we just further solve, this should be negative 4 upon 4 plus minus negative 4, negative 240 upon 4. And considering this can be written as negative 1 plus minus. If we just solve this down, we know that 240 LCM can be written as 2, 120, 260, 230, 215, and then we can have 5, 3, 3, 1. So these are your factors of 240. And when we have 240, we can write down this as 2 into 2 into 2 into 2 into 5 into 3 into negative 1. And this whole thing will be in the under root, which means 2 into 2 is 4, under root 4. This should be under root 4, under root 5, under root 3, under root negative 1 if we just solve this thing now. So under root 4 is 2, under root 4 is 2, 2 twos are becomes 4. So the end result for this should be, 4 under root 5 under root 3 iota upon 4, which means 4 and 4 is cancelled out. And considering the same values, let's just have them considering the same values. We can always write down this thing as x is equal to negative 1 plus minus 5 under root 5 under root 3 iota. So the two values that we will have is, the two roots we'll have is negative 1 plus 5 under root 3 iota, negative 1 plus under root 5 under root 3 iota. Or we can always write down this thing as negative 1 plus minus under root 15 iota. So both ways it is accepted. So there's another question example in front of you, and the question says evaluate the roots. Let's say evaluate the roots. And when we know that we have a quadratic equation, we'll be solving minus b plus minus under root b square minus 4ac upon 2a. This will give me value for x. So x will be negative 2 plus minus under root negative 2 square minus 4, 1 and 5 upon 2. A should be 1. So knowing that, the answer for this would be 2 plus minus under root 4 minus 4 1 is 4, 4 5 is 20 upon 2. The answer will be 2 plus minus under root negative 16 upon 2. So just have two different fractions in this, under root negative 16 upon 2. This is cancelled out as what? 1. Under root negative 16 can be solved as 4. So this should be under root 16 and under root negative 1, 4 iota. So this should be plus minus what? 4 iota upon 2. So the end result that we will have is plus 1 plus minus 2 iota. That means you will have two different root, 1 plus 2 iota and 1 minus 2 iota will be the answer for this particular question. So using what? Quadratic formula to find out the roots and using the complex number iota in it. Okay, Ji. Moving forward, when any quadratic equation have complex roots, then the roots of that equation are conjugate to each other. Now, what does conjugate mean? Conjugate means that if I say we have 1 plus 2 iota, then the other root will be 1 minus 2 iota. when we always change the sign of the second value. If it is 3 plus 4 iota, the other root will be 3 minus 4 iota. So these will be the two roots. If one is 2 plus 2 iota, the other root will be 2 minus 2 iota. So these are the conjugate roots. So whenever there is one root given and we need to find out the other root, we will always conjugate. Now, knowing the fact that the question sometime if roots are given and you need to find quadratic equation. If roots are given and you need to find out quadratic equation, we use formula which is y is equal to x square minus sum of root of x plus product of root. Sum of root and product of root. Let's just do the example. Sum of root and product of root. If one root of quadratic equation is 1 plus 2 iota. Now this is your question. Find quadratic equation. Find the quadratic equation. Knowing the fact that since one root is 1 plus 2 iota, so other root will be 1 minus 2 iota. Since the formula says y is equal to x square minus sum of root of x plus product of root. So 1 plus 2 iota plus 1 minus 2 iota. So this will give me what? Sum of roots. So this should be 1 plus 2 iota plus 1 minus 2 iota. When we have this value, considering this, we can always say that the answer for this is 1 plus 1 plus 2 iota minus 2 iota. This is cancelled out, so we are left with what? 2. So sum of root is basically 2. If we find out product of root, that will be 1 plus 2 iota and 1 minus 2 iota is multiplied. And when we multiply this 1 should be multiplied with 1 should be multiplied with minus 2 iota, plus 2 iota should be multiplied with 1, plus 2 iota should be multiplied with minus 2 iota. So, in this regard, what we do is, we solve this by 1 into 1 is 1, minus 2 iota, plus 2 iota, and this should be 2 into 2 is minus 4 iota square. Minus 2 iota plus 2 iota is cancelled. We are left with 1 minus 4 iota square. Iota square is minus 1. Iota square is minus 1. So this should be negative 4, negative 1. So 1 plus 4. So the answer for this should be 5. So product of root is 5. So considering that the equation was y is equal to x square minus sum of root of x plus product of root, and we write down this thing as y is equal to 1 plus 2 iota x square minus 1 plus 2 iota plus 1 minus 2 iota x plus 1 plus 2 iota multiply 1 minus 2 iota. So the answer for this is x square minus 2x plus 5. So the end result is x square minus 2x plus 5. This will be the answer for the root equation from the roots. Representation of complex number. There are four different ways your complex number is represented. Number one is in the form of Cartesian, which is known as, that means complex number will normally be written as for Z, which is shown as A plus iota B. This A is without the iota, so this is real value of Z, whereas this thing should be the imaginary value of Z because this represents the iota itself. Your real value of Z on the x-axis is represented on the x and y-axis is represented on x, whereas your imaginary value is represented on y. So if the normal example question, let's say we had 1 plus 2 iota, so this normally is the Cartesian form, which means this is your A and this will be your B. So A is 1 and B becomes what? 2. So this is your normal Cartesian form. So this is your first way to write down the represent or to represent the your complex number. The second way is the trigonometric ratio. The second way is the trigonometric ratio, which is generally used as Z R cos theta plus iota sin theta, which is R cos theta plus iota sin theta. Now, in which you need to understand that you need to find out the value of R and the value of theta as well. But to find out value of R will be the modulus of Z. Modulo of Z will be that we will be writing down under root A square plus B square, which means when the real value, then when this means when the Cartesian value is given, which is A plus B iota or A plus iota B, this will be your A and this should be B written down in the modulo of Z formula. Whereas if I want to find out the theta, or let's say we need to find out the alpha, we use tan inverse B upon A. We use tan inverse B upon A. Now, normally, this is your R, which is represented as length or the modulus. And in theta, we normally say this as argument. That means the argument is tan inverse B upon A. So normally in this form, if we just realize that this is your real value of Z and this is your imaginary value of Z. So if I want to write down R, which is Z, this can be written as real value of Z square plus imaginary value of Z square, which is A square plus B square. For theta or alpha or argument, we have tan inverse, which is imaginary value of Z upon real value of Z. So to find out the R and to find out the theta, we have the formula. When we will be finding out the theta and the R, then we will substitute the value in the trigonometric form. We will be getting the trigonometric form directly. The third form is the exponential form, which is Z is equal to R e to the power iota theta. And R and theta will be found out just like we found out in the trigonometric form, which means R will be under root A square plus B square, whereas theta will be tan inverse is equal to B upon A. The fourth form is the polar form, which is Z is equal to R This can be written as less than theta. That means R, you'll be finding out the same way. Theta, you'll be finding out the same way. In this representation, this will be known as your polar form. Remember that if Z is A plus iota B, then the second root for this should be A minus iota B. This should be the conjugate. This will be the conjugate of Z complex number.